Namaste and a very good morning to all of you. My name is Mithun, and in today's video, I'll be talking about image segmentation. If you have a set of images, how will you segment these images into different groups? This will be the topic of our discussion. Many times, the data can be in the form of a spreadsheet, wherein we have variables like age, salary, previous experience, so on and so forth, which is structured data. Equally, there are times when the data may be unstructured. Data can come in different shapes and sizes. If we have the data in the form of audio, video, or text, how will you process such data? Here, I'm specifically interested in processing image data. I would segment these images. Let me show you the source data that I have. So I have a set of 19 images. I have saved this in the folder which is called as domestic animals. So some of these images, you can see you have the first image, which is of a calf. Then you have the image of a cat, a chick, a cow, so on and so forth. I've got 19 such images. If you were to have numeric data, it would be pretty easy. We would process it using k-means cluster analysis or hierarchical cluster analysis. But when we have image data, it is not easy for us to process it. Simply because human beings can understand images, human mind can process images. But when it comes to machine learning algorithms, excuse me, when you talk about machine learning algorithms cannot understand images. Machine learning algorithms can understand numbers. So how will we go about segmenting these images? To perform image segmentation, I will be using Orange. You might be familiar with Orange. First things first, if you have downloaded Orange, usually the feature called image analytics will not be available. If I scroll down and hover the mouse over image analytics, you can see this feature displays all the tools that we need to process images. But this feature of image analytics is not available when you download Orange without installing the image analytics add-in. So the question is, how do I install image analytics add-in into Orange? To install image analytics, please go to the options menu. The third option from the top is what is called as add-ons. Let me click on this. Here you can see the different features that you can install. Now, if you're interested in installing image analytics, you might want to select this particular option, image analytics, and then simply click on OK. This will help us install image analytics. Since I've already selected image analytics feature, I will not again reinstall this. I'll simply click on cancel. After you install image analytics, you might want to restart the machine for this particular feature to be displayed in Orange. Okay, we are all set to start. First thing that I would like to do is, I would like to load all these 19 images into Orange. How do I load these 19 images in Orange? Let me come back to Orange. To load image data, what I will do is, I will click on the first option, which is called as import images. As the name itself suggests, it helps us import images from a directory. Let me click on this particular widget. The widget appears in the blank canvas. I will double click on import images. It is taking me straight to domestic animals folder. If it doesn't, you can choose the browse option Once you choose the browse option, you can select the folder which contains the image files. I have selected domestic animals and I will click on select folder. You can see here, right now it has loaded all the 19 images that are present in the folder domestic animals. Let me close this particular window. Now you have loaded 19 images using the import images widget. What next? The next step would be to visualize these images in Orange. To view these images, I will use the option Image Viewer. Let me click on this particular option and establish a connection between import images and Image Viewer. Let me double click on Image Viewer. There is a message that is being displayed. I'm not interested in this, so let me close this message. You can see here now Orange displays all the images that you had seen in my original folder. You can see here the images of calf, hen, horse, lamb, ox, rabbit, so on and so forth. There's also a stray image of a kid here. We can just ignore this for time being. Let me close this. So there are two widgets. One is to import the images. Second one is to display the images after loading this particular directory. What next? The next step would be to see the data that is present. To display the data, you can click on the option data. And here there is a widget which is called as data table. What does this option do? It helps us view the data set in a spreadsheet. Let me click on this particular widget and then establish a connection between import images and data table. Let me open up this particular widget. What do you see here? You see metadata. What is metadata? Metadata is nothing but data about data. You have the names of the images. You have the second column, which is image description, size, width, and height. This is a bit disappointing because this does not help me in machine learning. This is just the characteristic of the image that I have. Now, there is a very, very important problem that none of these columns are useful in machine learning. So what is the problem that we have in our hand? The problem is we need numbers which describes the content of the images. You may ask me, why do we need numbers? I've already told you that a machine can process numbers. A machine cannot process images. So we have to find a way to transform the raw images into their vector representation. Using a deep neural network, we will be able to transform the raw images into their vector representation. Now, this deep neural network was trained on millions of real-life images. Now, once we convert raw images into their vector representation, the output of the transformation gives us vectors. These retrieved vectors are called image embeddings. I repeat, the output of the transformation gives us vectors. These retrieved vectors are called image embeddings. We embed our images into a multi-dimensional feature space. So how will we convert the raw data into images? This is not very, very useful. What you're seeing in your screen is not very useful. I would like to convert the raw data into images. To convert this raw data into images, what I'll do is I'll click on Image Analytics. I've already clicked on Import Images and Image Viewer. The third option is what is called as image embedding. Image embedding through deep neural network. Let me click on image embedding. Let me delete because there's an extra widget. I would like to establish a connection between my source data and image embedding. It is processing all the images, but let me open this up and show you some of the features that are present here. The default image embedder that Orange will use is what is called as Inception V3. I repeat, the default embedder is Inception V3. When I click on the drop-down menu, you see there are 6 other options apart from Inception V3. You see what is called as Squeezenet, VGGNet, VGG19, Painters, DeepLoc, and Openface options. All these are embedders that you can experiment with. I'd like to take a pause here and explain what is the difference between each of these. Now, to explain the difference, what I'll do is I'll just open up a Word document and give you a high-level perspective about some of these embedders. Let's begin with Inception V3. This is Google's Inception model trained on the ImageNet dataset. I repeat, this is Google's Inception model trained on ImageNet. So Google developed a deep neural network model, and they use the ImageNet database to train this particular model. So you may ask me, what is so special about ImageNet database? ImageNet database is a very large visual database which is widely used in the field of visual object recognition. Now, it is astounding the number of images that they have. They have 1 million plus training data. So you can imagine 1 million plus images that can be used for training your algorithm, 50,000 images for validating the model that you have built. And these models, these images are corresponding to 1,000 objects. These objects could be domestic animals, it could be a keyboard, it could be mouse. There are 1,000 classes of objects. So this is the kind of massive data set of images. So ImageNet is the database which was used to train the Google's Inception model. And this is a deep neural network model which helps us in visual object recognition. Let's make a move on to the second option, which is called as Squeezenet. This is a locally developed model. This is again a deep model for image recognition that achieves AlexNet level of accuracy. There is a very popular model which is called as AlexNet. Using the Squeezenet model, we can achieve the accuracy level which is very close to AlexNet, but there is an additional advantage here. That is, here when we use a Squeezenet, we'll have fewer parameters. So simply put, what is the Squeezenet model? It's a deep model for image recognition that achieves AlexNet level accuracy on ImageNet with 50 times fewer parameters. Fewer parameters, higher level of accuracy. This is what I want. So we can try either with the Inception model or we can go ahead with Squeezenet. Now, just as an additional piece of information, I'd like to talk about AlexNet level of AlexNet model. Now, AlexNet is nothing but a convolution neural network which has 8 layers. So this is 8 layers deep, and CNN models are considered to be a gold standard when it comes to image processing. RNN models are widely used for text, for modeling textual data. Second point about AlexNet is that it was designed by a person called Alex and Jeff. Now here again, we can load a pre-trained version of the network trained on more than 1 million images from the ImageNet database. So most of these models have been trained by running them on the same ImageNet database that we have trained for the Inception model. The pre-trained model can classify images into 1,000 object categories, such as keyboard, mouse, pencil, and many animals. So Squeezenet is a good model because it has 1,000 plus classes, and some of these classes are animals. Since the problem that I am dealing with is to segment images, I can go ahead with Squeezenet and experiment the same with the first model, namely Inception. What about the third model? The third model is what is called as VGG16. VGG stands for Visual Geometry Group. This is a 16-layer image recognition model trained on ImageNet. What about VGG19? This is a 19-layer image recognition model trained on ImageNet. So the first 4 models that we are talking about, all of these are deep neural network models that have been trained on ImageNet database, and ImageNet database has 1 million plus images for training, 50,000 images for validation. Let's make a move on to the fifth one. This is called as the painters option. Now the painters model is a model trained to predict painters from artwork images. The sixth option is the DeepLoc model. This is a model which is trained to analyze yeast cell images. The fifth and the sixth option are not very relevant here because the data that I have is about domestic animals. We don't have data about yeast cell images or painters. Let's look at the last option, that is the seventh option. Here we are talking about Openface. What is this Openface? This is a face recognition model trained on face scrub and Cassia web face datasets. So the last option here is not trained on ImageNet database. Here, the Openface model is a face recognition model which is trained on face scrub and Cassia web face datasets. The Cassia web face dataset is used for face verification and face recognition tasks. This particular dataset contains 4 lakh plus face images of 10,575 real identities collected from the web. So this is a high-level perspective of the different models that Orange offers. So we have image embedding. So we can choose any of these options. The default option is Inception V3. I will click on Inception V3. Now, what this does is the image embedding sends the images to the server and computes the embeddings remotely. Very, very important. Next step here is I would like to look at the output of image embeddings. How does the output look like? Let me show you the earlier data table. You just had columns like size, width, and height. It is not very useful. Now that I have used the image embedder, how does the data table look like? I can just copy paste the same data table, but here I will be establishing a connection between image embedding widget to the data table. Now, after I have used the image embedder, how does the data table look like? Let me remove a couple of options here. Visualize numeric values, color by instance classes. Let me remove this. This is what you are able to see. The first 5 columns are whatever you saw earlier. Now from N0, N1, N2, you can see this is the output of the image embedder. You can see here, there are numerous columns that have been created. If I scroll to the right side, there are thousands of columns that have been created. How many such columns do I have? We have 2047 columns that have been created by Google's Inception model. These are all numbers, as you can see. Now, this is the beauty behind image embedding. Earlier, I couldn't work on my image data. Let me just show you the data. This is how the source data looked like. A machine cannot understand these images at all. When it does not understand, where is the question of it processing these images? Now, thanks to the image embedder option, I've been able to convert these 19 images into 2000. I've been able to extract 2047 features from these 19 images. You can see the names of all the domestic animals. The first one is calf, second is cat, and the third one is chick. And all these are nothing but the column level information that I have. Now I can go ahead and use these columns. These 2047 columns can be used to identify the similarity of the different domestic animals and thus segment them. So these 2043, once you get these 2043 columns, it becomes like any other data analysis exercise. You have a set of columns and you can use them as variables, feed them into any segmentation technique, and you can group them. Since I have a sample of 19 here, which is a small sample, row-wise, I have got only 19 images. And to group these 19 images, I will use what is called as hierarchical cluster analysis. But first, let me close this particular window. Let me come back to Orange. So this is how we've been able to convert images. The next step here is to use what is called as distances. As the name itself suggests, I don't have a dependent variable here. If I would have had a dependent variable here, I would have used a supervised learning technique. I don't have a dependent variable here. I just have a set of variables. And from these set of variables, I need to look at the similarity matrix and club these images. So I will be using distances. Let me right click and you can see the option called as distances. When I hover the mouse over the distances option, Orange displays a message. It says it is used to compute a matrix of pairwise distances. So let me click on the option distances. I will not be connecting it from import images. Why? Simply because I will get an error. I will have to connect the output of image embeddings. Why am I connecting the output of image embedding? Simply because there are numbers here. There are 2047 numerical columns which can be used to compute the distances. Let me open up this particular widget, that is the distances option. You have a couple of choices here. Either you can compute the distances between the rows or you can compute the distances between the columns. Since I want to group the images, I will choose the option rows. What is the distance metric? By default, we will be using a Euclidean measure. But when I click on the drop-down menu, you see there are multiple options here like Manhattan's distance measure, cosine similarity, Jacquard measure, Spearman's measure. You also have absolute Spearman's measure, Pearson's measure, so on and so forth. Spearman's measure can be used, or Pearson's measure can be used when you want to find the distances between columns. I will avoid this for time being. Since I want to find the similarity between images, one of the best distance measure here would be cosine similarity. When you want to find out the similarity between two text documents or between two images, a preferred distance measure would be what is called as the cosine similarity. Now this will compute the cosine similarity. Now, once we have the distances widget, what is the next option? The next option is click on unsupervised learning. Once I have clicked on the unsupervised learning, you can see here, there's an option called as hierarchical cluster analysis. Orange gives me a message saying that it displays a dendrogram of a hierarchical clustering constructed from the input distance matrix. So hierarchical clustering expects me to feed the distance matrix. So I have already created the distance matrix. So since I have already created the distance matrix, what I will do is, all that I need to do is, I'll have to establish a connection between distances and hierarchical clustering. There are two widgets. I'll delete one of them. I don't need the second one. So this is where I have the distance matrix, which will be fed into hierarchical cluster option. Let me open up this, and what you're seeing in front of you is nothing but a dendrogram. You can see here, these are some of the images that we had, like a foal, you had a horse, cow, ox, goat, so on and so forth. And then you can also see here some of the birds like chick, duckling, so on and so forth. It looks like some of these, we have two groups here. All these things that you see at the bottom half can be put in one group, and the ones at the top can be clubbed into the first group. So you can see here a foal, a horse, a cow, ox can be put in the first group, while some of the other animals, domestic animals, can be put in the second group. Now you can also click on the linkage method and experiment with either a complete linkage. You have multiple options here. A Watts method. A Watts method is the default method, and this is pretty decisive. It says that there are 2 clusters. I'd like to see if there are 3 clusters or 4 clusters. Weighted method is not very decisive in the way it has formed clusters. What about average? Again, not very decisive. What about single? Not so good. You can click on complete. This is good. And the last one is Watts, which you have already seen. Now, this is not bad at all, because some of the birds have been put in the similar category, like it could be a turkey, hen, or a rooster. They have all been put in the same category. Now, let me just select these 3 birds. Let me close this. And here I will just say right click and choose the option image viewer. Now establish a connection between HCA, that is hierarchical cluster analysis, and image viewer. You can see here the 3 birds have been put in the same group. Now what you can do is, you might be thinking that this is a trick. I have selected deliberately all the similar photos and then I'm feeding it. If you want to experiment, you can experiment. You can go to Google Images. By the way, all the images that I had selected are all from Google. So credit must be given where it is due. There is a famous cow, which is called as the Bos indicus. So you can choose any of these images and check whether this gets classified in the correct group or not. I'm just looking at some of these images. I can choose any of these images. Let me choose this particular image. Right click on this, save the image. You can see here now I have 19 and this is the 20th image. This is the Bos indicus cow. So I have the 20th image now. If it has not been put into the correct segment, we might have to choose a different embedder. We might have to experiment with the different types of embedding that we have, like Squeezenet or any other type. Similarly, the similarity matrix also plays a role here. Instead of cosine similarity, we can experiment with any other similarity matrix. So all that I need to do is I will right click, and as of now it is reading 19 images. I want it to read the 20th image as well, which is of boss indicus. So let me click on the option reload. You can see here now all the widgets are basically getting updated. This is the additional image. Let me quickly choose the option hierarchical cluster analysis. Now you can see here, this is boss indicus. Now it has been clubbed with cow, which is brilliant. So you can select the cow, or for that matter, even the ox. And now once that you have selected this, you can just close this and go to image viewer. You can see the three images, namely boss indicus, you can see the cow, and you can see the ox. So this is how Orange helps us with image segmentation. This is brilliant, by the way, not so easy for us to segment. In case you don't get it right in the first time, you might want to experiment with the type of model, the deep neural network model that we have specified during the image embedding stage. Second, you can specify different methods to compute distances. And thirdly, you can experiment with the different clustering methods as well. I'd like to again call out that all these images are from Google Images. So again, credit must be given where it is due. In case you have liked this video, I request you to subscribe to my channel and hit the like button. Thank you very much for watching this particular presentation. Have a good day.